harm. It's just a physical quantity. See, like, let's say you want to go from a place P to place Q, and you want to go there in like we're talking about it in terms of speed, okay? Like, let's say you have to go in 1 hour. Ideally, it needs to take, like, if you go at a speed of like you went some way already up to here with some speed. Ideally, you need to go 70 kilometers per hour so that you can reach here in like 1 hour. You have already covered some distance, and since you're already moving, you're not starting from zero. 35 kilometers per hour है तुम्हारा speed. So you need to like accelerate to reach 70 kilometers per hour, right? So 70 kilometers per hour is the threshold that you need to reach. And how much do you need to accelerate from 35 to 70? So the difference is the activation energy.
Ma'am, you had said that activation energy is the energy required to activate the reaction.
Yeah.
That's what you said for
Reaction,
threshold
like,
energy also.
threshold energy is the overall, again, see, by giving the activation energy, you're making the molecules reach the threshold.
So like, can we say activation energy is the energy required to start the reaction, and threshold energy is the energy of the unstable intermediate?
Yes, you can say that. Okay, absolutely.
So threshold is not used to start the reaction.
No, that's just the energy value that you need to reach so that the reaction can happen. So this difference that is required by the reactants is the activation energy.
But when it's at threshold, then the reaction starts, right?
Yes.
And it's used to start the reaction.
So then how, if it's not required to start the reaction, then how is it the energy of the unstable intermediate? Like वो start होने के बाद ही intermediate form होगा ना?
Yeah.
You said that it's not the energy required to start the reaction, but like if we say that it is the reaction that the unstable intermediate has, it means that the reaction has already started. So how is it required for the reaction to start?
Again, it's like this all coming down to semantics only. You need to give the reactants activation energy, amount of energy, so that the reaction can go through. Why are you doing that? By giving it this much quantity of energy, you're making it reach the threshold. Got it? I don't get why you guys are confused in this. Like, what exactly is your confusion? Are you just troubled that both of them seem to have the same definition? Is that it? Okay.
Yeah, like what's the difference? I didn't understand based on the starting of the reaction.
So which energy starts the reaction? Which is the energy that starts off the reaction?
Both. I mean, that's a you can't. I mean, it's not like they're two different things. They're related things. Threshold energy is just the name we use to give this particular value. यहाँ पे y-axis पे जो है, just a second, guys. Yeah, sorry about that interruption. Threshold energy, activation energy, right? Okay, so we call this particular value that needs to be reached, absolute value, as threshold energy. Activation energy is the difference between where the molecules are at existing and what they need to reach. So as Sia said, like if the definition is what is troublesome, you can say threshold energy as the energy of the unstable intermediate complex that is formed during the reaction, and activation energy as the energy required to form the intermediate complex. Let's talk about it in those terms. Okay. So activation energy is energy required or needed in order to form the intermediate. And threshold energy is the energy of the unstable intermediate. During the reaction. Okay, happy? Satisfied? Cool. What else do we have? Yeah, so that's basically it. Other constants related. Oh, this is the first board related to this. Other things you need to note is, so the difference between the initial and the final. So this value minus this value, this is the difference in enthalpies or energies between the reactions and products, right? So this refers to your delta H. In this case, because products are at a lower energy than reactant, matlab energy is released, इसलिए कम हो गया. So this represents an exothermic reaction. Okay. So based on this, can you figure what an endothermic reaction ka this thing will look like?
Delta H represents what?
Enthalpy of a reaction. That's the usual delta H that delta H. Okay,
Oh.
delta
Yeah,
H.
yeah, yeah.
Huh. So endothermic के केस में कैसे दिखेगा? This thing.
endothermic as in it will absorb energy, right? So like heat. So
products ka, tell me where to stop. I'll just like continue the graph.
You have to stop above A
yeah,
plus B.
above
Okay,
yeah.
and B.
Yes. The absorb energy matlab products going to be higher. So this is C and D. So
But how is that related to the potential energy present?
when we say energy is absorbed, released, like potential energy is basically all of the energies of the molecule,
Combined, yeah.
right? Yeah. So
Yeah.
we're absorbing it, किधर जा रहा है, like it is being stored within the bonds. It could be within the covalent bonds, complex bonds, like जो भी है, it's different for different cases, but it is stored within these things. Could have been like one oxidation state is more stable than the other oxidation state. In that case, yeah, takes energy to maintain that unstable one. Some bonds, hybridization,
Yeah, okay.
factors. Same thing. Concept is the same. Difference between reactants and products. This is delta H, the reaction. And यहाँ से यहाँ तक, this is the activation energy, same thing. Another tidbit, like when you're increasing the temperature, molecules have more internal energy, like more kinetic energy, more speed, more everything. So you're essentially cutting down on the activation energy required. So instead of starting from here, at a greater temperature, you'll be starting from somewhere here. So lesser time required to get to the threshold. Okay, let me know when you guys are done noting. We'll go to the next part. So what happens when we increase the temperature? We kind of discussed it qualitatively that increasing the temperature increases the kinetic energy of the molecules. So you have to go a little bit more quantitatively. You go back to, do you guys remember this from grade 11? Does it like spark any memory? Maxwell-Boltzmann distribution. Yes, no?
Remember there was Boltzmann constant.
That's a different, yeah, there's a constant, yes. But Maxwell-Boltzmann distribution hai. Matlab, this is another graph. You remember it? Okay.
I don't think we've done this, but
No, you have. States of matter, when we're discussing that. Do you guys remember the kinetic theory of what was it, gases?
Yeah.
So it's in that context that this is done.
Oh, that chapter was only for 4 marks.
What does that have to do with it?
So we did study it. Like,
important
I
है.
barely read it just like that.
No, I don't remember this.
Also, we weren't with you in 11th, so
Yeah.
Okay, that's why I'm asking, do you remember, do you not remember? Like, simple, no. But glad to know, like, you're aware of the syllabus. Um, okay, so Maxwell-Boltzmann distribution, this tells you the distribution of velocities. So y-axis pe you have the velocity of molecule, and x-axis pe you have the fraction of particles, molecules, atoms जो भी है, that have that particular velocity. So basically you measure, this is a very hypothetical situation, like it would be very difficult to do it in real life because yeah, lots of molecules. But if you take every particle, measure kitna velocity hai uska, and then plot it on a graph. So you take the
I
fraction.
think we did have
that
something like
velocity.
this.
Yes.
I remember asking ma'am why did we have fraction, but I don't know if this was for this.
Yeah.
Yeah, it was.
Like,
Yeah.
right? And then there's like many different analysis that you take the maximum probable velocity, mean velocity, RMS velocity, pura hota hai, but yeah, whatever. But yeah, the distribution kind of looks like this, like this much, 1% of the molecules have this much velocity, 2% will have this much, 3% will have this much, that way, kind of has this sort of a curve. Do you remember how, like, what the curve looks like when temperature is increased? No? So when the temperature is increased, the curve is flattened a little bit. So more number of, number of particles is the same, matlab total fraction will be the same. So the fraction of molecules having the highest velocity increases, like more particles will have that maximum velocity. So kind of it is flattened a little bit. So it kind of looks like this. So the peak shifts to the right. So more more number of particles will have the highest velocity, and kind of looks like this. I'm doing a very bad job at it because it's like freehand drawing, but yeah, kind of like this. So number of particles having maximum velocity increases. This is at T plus 10 degrees Celsius. The red is T plus 10. The black is T. Red is T plus 10. Wait, there's another. Let me just do it in the center. It's a different thing. 1 second, guys. So the fraction is on the y-axis, and kinetic energy is on the x-axis. It's kind of like this. This is at T temperature. Then at T plus 10, when you increase it, kinetic energy increases. So the peak shifts to the right. And the number of molecules having that flattened a bit. Yeah. kind of like this, something like this. So this is at T plus 10 degrees Celsius. Okay. So, okay. So the reason why we are discussing this is at a molecular level, suppose this is the activation energy, EA. Like all of these are values of kinetic energy, right? So you have molecules having different kinetic energy. You have like really slow molecules, really fast molecules also. One particular energy is the like you need the molecules to have this much energy for the reaction to happen. Then threshold energy, like this is the threshold. EA would be wrong, but this is the threshold energy. Then if I draw a line, so you can see that the fraction of molecules having like that have reached the threshold energy has increased at the increased temperature. So that's kind of the explanation, like an in detailed quantitative explanation behind why there is an increase in the number of effective collisions. Why there's an increase in the rate? Because the number of increased like the number of effective collisions has increased. Why is that the case? Because simply a greater fraction of molecules have that amount of energy, so that they will undergo the effective collisions. I'll put it stepwise. So increase in temperature. So let's say if T increase.
So this is an explanation for that Arrhenius one.
Huh.
Oh.
It's all the same thing. Like Arrhenius is giving you a mathematical formula, and this is like an in-depth explanation. Like first 15 minutes may whatever I discussed, it's the same thing with like extra reasoning and extra data. Like, yeah. So if temperature increases, rate increases. Why is this? The reason for this is because there's an increase in the number of effective collisions. So use the like collisions to happen. This is the part where I explained. If the energy is less, any of the molecules in this particular bracket, if they come towards each other, they will collide, but they'll just split ways. Reaction will not happen. So effective collisions ke liye, you need that much amount of energy so that when they hit, they form that intermediate complex in that angle. The number of effective collisions increases. And why the number of effective collisions increases is because this simply, it's like a numbers game. It's just statistics. You have more number of molecules available to undergo that number of effective collisions. So if I have to put that in words, the why behind this is there's a greater fraction of molecules that are colliding with uh, with like with the sufficient or required amount of energy. Like they're fulfilling the required conditions to have effective collisions. So it's like a greater fraction of molecules that can attain the activation energy faster, easier. So the equation, yeah, this particular analysis is not there. Yeah, that's it. Then we'll talk about the effect of catalyst. The numericals related to this formula Arrhenius equation, you don't have it. That part is not there. But the theory behind it, explanation, reasoning, all of this you need to know.
What is on the y-axis?
So this is the fraction of molecules. Numerically, it's represented by Ne by Nt. So the number of molecules that have a particular energy out of the total number.
Number of what?
So
Number
Ne
of?
is the number of molecules or particles. Ne is the number of particles or molecules that have E energy. E is a variable, so that depends on the x-axis. Itna energy tak kitne, how much, this much, how much, this much energy, how many molecules have this much energy, and so on. And Nt is the total number of molecules. If you take 1 mole of molecule, so you have 6 into 10 power 23, उसमें से इतना energy किसमें है? That way. Have you guys not decided, but do you know what you'll be doing after 12th? Like broadly, will you go into research or um, work like corporate or like roughly? If you have to write explanation of what happens when temperature increases, it'll go the other way around. So when there's an increase in temperature, um, the distribution of molecules, the kinetic energy distribution shifts in this way that greater fraction of molecules are present that are colliding with the required energy are present. So that would result in greater number of effective collisions. So since there are more number of effective collisions, that means that the rate of the reaction also increases. More collisions means more of the reaction is happening. So that increases rate of the reaction. Okay. That gets us into the effect of catalyst. Effect of catalyst, I mean, Sia or Arya, can one of you guys like take over what happens when catalyst is added? The quantitative part of it, like I'll do that, but I want to see like how much. I think you guys must have already studied, na, like catalyst ke bare mein, similar stuff.
Then the reaction proceeds forward faster.
Yeah, how the mechanism behind it, or okay. The first thing is definition of a catalyst. What do you mean by a catalyst?
It alters the rate of the reaction without taking part in the reaction itself.
Yes. So 2 points to a catalyst. One is increases the rate of a reaction. The second is without itself getting altered in the process, without itself getting changed in the process.
It also doesn't change the delta G gives free energy of the reaction, something like that.
Yeah. So that I'll show it graphically. Okay. So without itself undergoing change, this is the main thing. And opposite of a catalyst, if the substance
Inhibitor.
yes. So if the substance increases the catalyst, if it reduces the rate of a reaction with same mechanism without undergoing any change and all that, it's called an inhibitor.
So, but I thought catalyst can be both promoter and inhibitor. Catalyst is only promoter.
Promoter is something that increases the effectiveness of the catalyst. So promoter poisoner acts on the catalyst. Catalyst inhibitor acts on the reaction. Yeah. So then you have promoter, which affects the catalyst. It increases the effectiveness of the catalyst. Makes the catalyst more effective. If you want to control it, then you use a poisoner. So this makes the catalyst less effective, poisons the catalyst.
If you had to reduce the effectiveness of a catalyst, why would you put a catalyst in the first place?
So that the reaction can take place. Like you want to like in sometimes you want to control the reaction. You don't want it to be a runaway thing.
Yeah. So
Yeah.
that's when you add a poisoner.
Yeah.
Is inhibitor a type of catalyst or is it something different?
You just, like you just add a substance to a reaction. If it increases the rate of a reaction, you call it a catalyst. If it reduces the rate of a reaction, you call it an inhibitor. They're opposites of each other. Yeah. Catalyst means it increases. It's not like types of catalyst or anything.
I remember in that graph, I think we did this in biomolecules. I don't know. But I remember in that graph with the catalyst, the activation energy was like, no,
Yes.
without the activation energy was lesser, and with something, no, it was ulta. Sorry, with the catalyst, activation energy reduces, and
Yes.
without, it was more.
That is why it increases the rate of a reaction, because then it became easier for the molecules to cross that threshold. Yeah.
That was in biomolecules, na Sia?
I think so, yeah. Yeah, with enzymes.
Yeah. All catalysts universally they work the same way. So whichever reaction you draw the graph, the individual values may change, but the shape kind of is the same. Okay. Then how it works. So activation energy come kaise ho gaya? Like it provides an alternate pathway. Provides an alternate pathway for the reaction to take place. So this alternate pathway provides an alternate pathway which has a lower activation energy. That way, more number of molecules can attain it like easily. इसलिए rate increases.